In this video, we will talk about capabilities and use cases. So these are the capabilities and use cases. So in GenAI, it is used for drug manufacturing by mixing and matching the different combinations of proteins, which if you do manually, it takes a lot of time. But using compound computing, it becomes very easy and it is used in a big way. Then document summarization is another capability of GenAI. Then answering questions either based out of an Excel sheet or from a text file or from a PDF file or from a Word document. You have to specify the source and then you can create your prompts based on these documents. Then writing drafts, emails, proof of concepts, etc. So you need to give the relevant prompt and it is going to generate the responses based on your input. Chatbot is having an agent to agent kind of a communication. So you can create an application where you assign something called as a user. Okay, so you can create let's say you can define something and set the context and the chatbot will be run according to that context. Okay, so let's say it is a conversation between a patient and a doctor. Okay, so you can set these context programmatically and then it is going to be used as a two-way communication. Then document editing and image, video, artwork creation. So all these things are available as part of the applications. So DALL-E is one example. So similarly, you have lots of other examples where you can use it for free for a limited period of time. And then you have to pay for the other services. So this is the synthetic data creation, where if you do not have enough data, then you can create the existing or the balanced data by having the original data as your reference. Now I have given you one use case where you will be required to create this data, the synthetic data. That is when you don't have enough records. So that is the first case. Okay, when there is not enough data. Okay, so in case of missing data, we might probably use, okay, so I'll take that. So data is missing. See, this can be used when you have bias in your data. Okay, when your data is heavily biased. I'll give you one example. Now, let us say that you are given a task of building a classification model to identify whether a transaction, a credit card transaction, is a fraudulent transaction or a normal transaction. Okay, so this is given by some bank and this has to every transaction has to be predicted as a good transaction or a fraudulent transaction. Now you have, let us say, let's say you have 1000 records. Now, what do you think will be the distribution of the two classes, fraudulent transaction versus a normal transaction? So how many N's will be there? How many F's will be there given you have 1000 records? So out of, let's say, 1000 transactions, how many frauds happen in today's world? What do you think? Will it be even? Will it be 500 each? Or will I have more of good transactions? Let's say 900 good transactions and maybe 100 fraud transactions. Will it be like this? So the likelihood that my data will have more of good transactions is high. Okay, now because we have so many secure features, it's very rare that you can have a fraudulent transaction. Okay, so my data is biased towards good transaction. Okay, so here the bias is in a good way. So here I have an imbalance in my class. So this is called class imbalance. So if you look at the good transaction versus the fraudulent transaction, it is how much? 9:1. That's the ratio. Now, if I'm trying to build a model, so you can probably guess that most of my records will be predicted as a good transaction and not a fraudulent transaction. Okay, so which may not always be the right prediction. So when I have this kind of a scenario, then I need to really pump up the records which has fraudulent transaction. I need to have more synthetic data for these records, such that my ratio is probably something like this, maybe 3:2 or maybe 3:1, something like this in this ratio, so that you can reduce the biasness of these classes. OK, so this is used a lot. I have used this many times, and it does make a big difference when you pump up the minority class and make it somewhere close to this, or even the other way around when you want to reduce the majority class and bring it to the minority so that they are balanced. Not exactly balanced, but to some extent they balance out. OK, so this is another scenario where I can create the synthetic data so that I can do a proper classification or regression. Then, of course, we have the coding assistance, tab 9 Copilot. So you can show this demo by logging on to any of the IDE, and you can say you can give a comment on, let's say, Java program and what you want, and you can say, OK, see, this is how the comments based on the comment, this is how the code is generated. And you can also show them what are the different types of code that is given in the answer. OK, so for example, if I write a comment saying write a JavaScript to sort a list of numbers. So when you press Control Enter, you will get a couple of suggestions. So show them that these are the suggestions. So 1, 2, 3, all these things will be there. And how are these suggestions different from each other? How do you select the suggestion and how do you ensure that these suggestions are good? So you can maybe take the first one, run it, and compare that with the second one, and tell them how to select the right code matching the standards that is set by the company. Thank you, everyone.